Good morning, all of you. This is the internal assessment presentation video from chapter Nitro compounds. Nitro compounds are an important class of organic compounds that are recognized by the presence of one or more nitro functional groups bonding directly to the carbon of the hydrocarbons chains or aromatic rings. Nitro compounds are usually prepared by different synthetic techniques, but a few of them are naturally occurring. Nitro compounds are explosive in nature, especially when they contain more than one nitro group. It is because of this reason nitro compounds has often been classified as explosive groups. The explosive nature of this group is due to the fact that the thermal decomposition they yield molecular nitrogen plus considerable amounts of energy is also released. Some of the most common explosive compounds are trinitrophenols, trinitrotoluenes, and trinitroresorcinols. Nitro compounds are considered to be derivative of hydrocarbons in which one or more hydrogen atoms are substituted by nitrogen groups. There are further classified as aliphatic aromatic nitro compounds depending upon whether the nitro compound is bonded to an alkyl or aryl group. Aliphatic nitro compounds, also called as nitroparaffins, are colorless liquids used chiefly as industrial solvents: nitromethane, nitroethane, nitropropane. They are further classified as primary, secondary, tertiary depending upon whether the nitro group is bonded to primary, secondary, or tertiary carbon atoms. In aromatic nitrogen compounds are called nitroarenes. One or more hydrogen of the benzene ring are substituted by nitro group. Some of important aromatic nitro compounds are nitrobenzenes, M-dinitrobenzene, P-nitrotoluene. Nitro groups are well differentiated from their isomeric nitrous esters, commonly called alkyl nitrides, in which the carbon is not directly bonded to the nitrogen but to the oxygen. Structure of nitro group. Nitro group is considered to be a resonance hybrids of two equivalent canonical structures, first and second. The sigma bond skeleton of the nitro groups involves the use of three sp2 hybrid orbital to the nitrogen, forming three sigma bonds, one with the carbon of alkyl group and the two with the oxygen group. But the nitrogen still has one unhybridized p orbital with the unshared electrons pair, and each oxygen atom also have one half-filled p orbital. These three orbitals overlap sideways, producing a delocalized molecular orbital, which encompasses all the three atoms. The hybrid structure is supported by the fact that the NO2 NO bonds length are same, 121 picometer, which is less than the NO single bonds but more than the NO double bonds. Thus, the structure of nitroalkane is isoelectronic with the carboxylate anion structure. Nomenclature. According to the IUPAC nomenclature, nitro compounds are named by adding the permanent prefix nitro to the name of parent hybrid. The position of any substituent, if present, is however indicated by the Arabic number 1, 2, 3, etc. With the carbon bearing, the nitro groups gets the lowest priority number. Method of preparation. First, preparation of nitroalkanes. From saturated hydrocarbons, alkenes react with nitric acids or dinitro-tetroxides in the liquid or vapor phase to form nitro derivatives. Hence, the reaction is called vapor phase nitration. CH4 plus HNO3 in presence of 675 Kelvin, CH3NO2 nitromethane plus H2O. When higher alkanes are nitrated, mixture of nitroalkanes including those formed by the ruptures of a carbon bonds are carbon-carbon bond are also obtained. As nitroalkanes are chiefly used as the industrial solvent, as a result in this method is widely used for commercial production of nitroalkane, as the mixture of nitroalkane formed can be separated by fractional distillation. Available evidence suggests that the preparation produced by free radical mechanism. Second, from unsaturated hydrocarbon. Alkenes are nitrated in the good yield by dinitrogen tetroxides in presence of oxygen to give a mixture of weak dinitro compound. Base catalyzed elimination reaction leads to the generation of nitroalkanes. Third, from alkyl halide. Primary and secondary nitroalkanes are synthesized by heating alkyl bromides or iodides with lithium, potassium, or sodium nitrates in dimethylamide or dimethysulfoxides. Nitrite ion being an ambient nucleophile has two sides, oxygen and nitrogen, through which it can attack alkyl halide. Attack through nitrogen gives nitro compound, whereas attack through oxygen gives nitrides. However, better yield of the primary nitroalkanes may be obtained if silver nitrides in the place of sodium nitrite is used. This method of preparation is not stable for the synthesis of aromatic compounds. From halocarboxylic acids, lower member of the nitroalkanes are and especially nitromethane is prepared by reaction of chloroacetic acid with the sodium nitrate or potassium nitrite. Nitroacetic acid, which is formed as an intermediate product, decarboxylate to yield nitromethane from amines. Primary amines on oxidation with the upper acids through a series of step yield nitro compound. Primary amine in which the amino group is bonded to a tertiary carbon can be oxidized and potassium permanganate in aqueous acetones to nitro compound in 70 to 83% yield. Preparation of nitroarenes. Aromatic hydrocarbon react with the concentrated nitric acid directly or in the presence of a strong acid catalyzed, namely sulfurous acid, to form nitro derivatives. Since hydrogen is replaced by monovalent nitro group, this reaction is called nitration. The selection of nitrating agent depend upon the reactivity of substrate. The most common amongst them is a mixture of concentrated nitric acid and concentrated sulfuric acid known as nitrating mixture. Concentrated sulfuric acid is used as it accelerates the nitration process by increasing concentration of electrophile nitronium ions. However, nitration can also be carried out with potassium nitrate or by using nitric acid in the presence of acetic acid or organic solvents. Evidence for nitration taking place with the formation of nitronium cations comes from a number of sources. On electrolysis, a solution of nitric acid in fuming sulfurous acid, nitric acid migrates to cathode. Salts such as nitronium perchlorates and nitronium fluorates have been isolated. Raman spectra successfully points to the presence of nitronium cation in this solution. Mechanism. The nitration reaction is initiated by the acid catalyzed dehydration of nitric acid by concentrated sulfuric acid to form the electrophile nitronium ion. The active species in the reaction and the one responsible for the incorporations of nitro compounds onto aromatic ring. The mechanism involves the reaction of electrophile nitronium ion with the aromatic rings to form intermediate sigma complex or uranium ions, followed by removal of a protons by the bases hydrogen sulfates ion to form the nitro derivatives. Physical properties. Nitroalkanes are moderately toxic colorless liquids with pleasant agreeable odors, with their aromatic counterparts are colorless or pale yellow liquids or solids with some distinct odor, like that of bitter almonds. All nitro compounds are highly polar and they have large dipole moments in comparison to the other organic compound. Hence are useful solvent for the some ionic reactions. Due to the polarity, nitro compounds are higher boiling in comparison to the parent hydrocarbon of comparable molecular mass. Besides, they also higher boiling in comparison to the less polar isomeric alkyl nitrides.